Okay, so we are going to complete this portion of Unit 5 by looking at writing quadratics. So we have learned how to graph quadratics, how to tell the transformations. Now we're going to be writing quadratics. So in order to write a quadratic function, you need the vertex and a point. And then here's our steps. So if you want to pause and then write down your steps, you can do that. Your first step is to label. I'm going to get my highlighters here. So your first step is to label the vertex HK and the point. The second step is to substitute the values in vertex form. So remember, our vertex form is a times x minus h squared plus k. Then we're going to solve for your a value. And then our last step is to rewrite the function in vertex form. So 4 steps: label, substitute, solve, and then rewrite. So let's look at our first example here. Our first example tells us that the vertex is 2, 3, and that our point is 0, 7. So my first step is to label the vertex HK and the point XY. So our HK, that's H and that's K. This is X and Y, right? So our vertex is always HK, and then the extra point we're going to label XY. And so let's think about our vertex form. Y equals A times X minus H squared plus K. Right, now our second step is to substitute the values into vertex form. So I'm going to put the 2 in for H, the 3 in for K, the 7 in for Y, and the 0 in for X. So here's what I have left. I'm going to bring down A. I have my parentheses here, and then I have this minus sign in here and plus. So let's go ahead and work this out. We're going to do what's in parentheses first. We're going to go back to our order of operations, do what's in parentheses first. So 0 minus 2 is negative 2 squared plus 3 equals 7. So negative 2 squared is positive 4. So we have 4a times 4, which we can write as 4a, plus 3 equals 7. And now we're going to solve for a. So just like we would do a regular equation, we're going to add or subtract 3 first. So we have 4 equals 4a, and then divide by 4. So a equals 1. So we have our a value. Now our last step is to rewrite the function in vertex form with a, h, and k. So here's the values that we're rewriting. We're not going to use the point again. We're just going to be using a, h, and k. And so we're going to write it back into this vertex form. So our answer for this is y equals 1 times x minus 2 squared plus 3. So this is our function. So we could actually write this and see if 0, 7 is on that graph, and we would be able to see that 0, 7 is in fact on the graph. All right, let's do another one. We're going to add a step to it. So here's example 2. We have vertex, this is a good one, is negative 1, 4, and our point is 1, 8. So I'm first going to start by labeling, right? Label H, K, and X, Y. And then I'm going to plug it into my vertex form. So y equals a x minus h squared plus k. And so we're going to put our y value in first. So we have 8 equals a, and then 1 for x. And look at this, we have minus a negative 1 squared, and then plus our 4. So this one's a little bit different because we have a negative h value. So if we have minus a negative, we know that it's going to be plus a positive. So we have 8 equals a times 2 squared plus 4. 2 squared is 4, so we have 4a, just bringing everything else down. Subtract 4, solving for a just like we did on the other side. 4a, oh look, we get the same answer, that's nice. So a equals 1. So when I rewrite, I'm just taking my hk and my 1 and I'm rewriting it. Y equals a is 1, x minus -1 is +1 squared plus 4. Okay, so that's my answer. But the next thing that we're going to want to do is to rewrite our vertex form into standard form. So I want to show you how to do that. So let's, in our notes, we're going to say we're going to write vertex to standard form. So here's your steps. You're going to FOIL or multiply the squared part. And 2, the second step is combine like terms. So not too many steps. It's just sometimes it could be tedious. Combine like terms. All right, so let's take our example from our second example, y equals 1 times x plus 1 squared plus 4. So when I say FOIL, this x plus 1 squared actually means x plus 1 times x plus 1, okay? So we have to multiply these together before we can combine our like terms. So you can either do first, outside, inside, last, or you can use your box method that we've done several times. So x plus 1, x plus 1. So we get x squared, x, and 1. Combine your like terms. So we have x squared plus 2x plus 1. Now we have this 1 on the outside and this 4. So if any other number were here, well, actually, even if we have a 1 here, we should distribute it. But because it's 1, it doesn't change anything. But you would use distribution there, plus 4. Now, our second step, combine like terms. So we have x squared plus 2x plus 5. So look at that. FOIL, multiply the squared part, and then combine your like terms. Now we have it in standard form where you have the ax squared plus bx plus c. So your next thing that you want to do is you want to go to your summary of notes here, and you're going to do those 2 examples. So before you go on to the practice, go ahead and do those 2 examples and check with Miss Holloway, or check with me, I'm Miss Holloway, before you go on to your practice, okay?